everyone. Today we are going to talk about 4.1. So chapter 4, it's about application of first order equations. And 4.1, growth and decay. So decay is opposite of growth, right? Okay, so the first one, we have interest compounded continuously. Then we have Q of T, Q naught. We read Q naught, 1 plus R to the T power. So Q naught, which is principal, and then R, we are using the rate, the first letter R, and T, time, first letter T, right? Okay, then if we have the interest is compounded n times per year, and they say that the account is multiplied n times per year by 1 plus r over n. Then we have, instead of 1 plus r, we have 1 plus r over n. And we saw this one before, right? In calculus 1. So we take the limit when n approaches to positive infinity, then we have 1 plus r over n to the n will be e to the r. Yeah. Okay. So instead of crazy formula, right? So if we have compounded continuously, then we can just using initial amount or principal, right? E to the r times t, right? So r means the rate, t means the times per year. Make sense? Okay. Now, let us do these questions. So if 150 is deposit, so that means that is a principal or initial amount, right? In a bank that pays 5.5% annual interest compounded continuously, right? So write the differential equation in this situation. So we don't have to solve, we just writing the differential equation, okay? All right, so let's talk about R first, rate, yeah? So we have rate, note, let me write down, note. Rate R equal to 5.5%, right? Okay, so since rate, we talk about decimal, right? So how do we convert to the decimal? We divide by 100, right? From the percent to the decimal. Then there will be 5.5, right? So 5 will be 5 over 100, which is 0.05, right? And 1/2 over 100, same concept, right? So we get 0.005, good, 0.005. So if we add, so 0.05 plus 0.005, we get 0.055, 055, which is, there will be 5.5, oh no, sorry, 5.5%, which is rate, right? Okay, now we can express, right? So we have the formula Q over T, which is Q naught e to the RT, right? So that will be initial principal, which is 150 e to the which is 0.055, right? So 0.055 and T. That's it. Make sense? All right. Uh, let's move on to other questions. So we have log y over t, retirement account balance in dollars after 2 years. Each year, the account earns 9% interest. You deposit 2% of your annual income. It's 46,000. So let's talk about this one, yeah? So deposit 2% of your annual income is 46,000, right? So, okay, so how do you calculate 2% of 46,000? That will be 0.02, right? 2%. So times 46,000, what do you get? Can you calculate? 920? Okay, good. All right, so let's do that. So, but let me read the last sentence. They say that it's growing and continuously. So I am writing continuous like this. Yeah. So if you don't know, let me write down. This is a continuous, continuous rate of 4% per year. Okay. Right? Differential equation. Okay. So the balance from interest plus balance from deposit, right? So balance from deposit we can express as initial principal initial Q naught e to the RT, right? Okay, then the first term balance from interest we have they say that each year the account earns 9% interest, right? So we're gonna say that let y equal to y be the retirement account money, right? Okay, so there will be, we can say that y over t equal to, then the first term will be, the interest will be 9%, right? So 0.09. Yeah, there will be 0.09 of y, because they say so, right? Each year the account earns 9% interest, right? And plus the initial will be 2% of your annual income is 46,000, right? So we calculate earlier, right? So 920. So 920 e to the R was, let me see. This is an R, this is not R, this is R, right? So 4%. So 0.04 T. Yeah, that is the answer, right? Oh no. We want to express as differential equation, so there will be dy over dt. Yeah. Sorry about that. So dy over dt. Okay, makes sense? Okay, very good. Okay, so let us do these questions A tank contains 70 kilograms of salt and 1,000 liter water. Pure water enters and drains. Let Y be the number of kilograms of salt in the tank after t minutes. Find dy over dt and initial and then solution, right? Okay. We did this one before in section 1.2. So let me show you this one. So next page, we have that. So from section 1.2, 60 kilograms of salt and 2,000 liter of water. Pure water enter 8 milliliter per minute and drain 9 liter per minute, right? Okay, so initial, this will be initial, right? So y of 0 equal to 60 kilogram, right? And then we talk about differential equation, right? Then inflow subtract outflow, right? And then there will be rate in minus rate out. So rate in is about rate pure of water entering. So previously 1.2, we had the number 8 liter per minute, right? Rate out, drain, so 9 liter per minute, right? Okay, so we talk about the initial. Okay, then the volume. So talk about the volume of solution in the tank, 2,000 liter. So we had in pure water in 8 liter per minute and there's zero salt, right? Okay, now drain. Drain is a different story because there was 2,000 liter with 60 kilogram salt, right? Okay, so drain out 9 liter per minute and we don't know how much kilogram of the salt and per total volume, right? So total volume will be, look, we have 2,000 liter plus 8 liters minus 9 liters. We calculate, right? Then 8 minus 9, we had negative 1 liter per minute, right? Okay, so there will be negative T there, right? That is outflow over the volume. Yeah. Okay, so we ignore the first term rating because we have a zero salt because only pure water in there, right? When you enter, right? So we talk about only rate out. So there will be the drain 9 liter per minute with, we don't know the salt kilogram, and we have about double volume, total volume, which is the 2,000 liter minus T. Minus T come from M minus 9. Yeah. So we are writing out only the second term, rate out. Yeah. That's why we get negative there. And then we talk about the unit at the time, right? So kilogram per minute. Yeah. Okay. So, and then I gave you a hint. What if pure water in 12 liter per minute and mix the solution drain 15 liter per minute, right? Then since enter 12, drain 15, their difference is negative 3t. So negative 15, y, we can just using that concept, right? From here, right? So the blank will be the liter, starting liter, right? How many water there, right? So 2,000 liter in that case. Yeah. So we are using that minus 3t. Make sense to you? Okay. So this is the same concept. Take a look. Just change the number. That's it, right? So rate in is inflow, right? Minus outflow, right? Okay. Now inflow, we talk about the rate times the salt, right? Okay. So enter is 6 liter per minute. How many salt is 0 salt, right? Minus rate times salt, right? So minus rate will be drain 8 liter per minute, right? And salt, we don't know, so why, right? Over the total volume. So the liter, 1,000 liter water and difference 8 and 6 and 8, which is 2, right? So negative 2t, right? Make sense? Okay, let me writing for you one more time. This is better. It's okay. Okay, 2t come from, right? 2t come from enter and strain. So 6L minus 8L, which is negative 2t. Yeah. Yeah. Because same concept with here, right? Yeah. That means lost 1 liter per minute, right? So we just indicate t, time t, right? So in that case, lost means lost 2 liter per minute, right? Make sense to you? Okay, so then we have dy over dt equal to negative 8 y over 1,000 minus 2t, right? Okay. And initial will be, let's see, 70 kilogram, right? So with y over 0 equal to 70 kilogram of salt. Is it clear? Yeah, I cannot see well, yeah? Okay, take a look this question. This question very similar, but the blue color sentence added there. Look, everything is same. A solution concentration 0.0175 kilogram of salt per liter enter 6 liter per minute, right? Okay, so let us do this one will be normally we had in that case 6 liter per minute and times 0 salt, remember? But in that case the concentration is 0.0175. Clear for you? Okay, so we have 0.0175 salt. Yeah. And then right side is the same. Minus, we have, oh, they said the same rate, right? So same rate, think 6 liter per minute, right? Okay, so we have 6 liter per minute. And then we don't know how much for salt, right? So that will be times y. Okay, then over 2,000 liter, right? Minus, in that case, 0t, right? Why? Because 6, note, 6 minus 6, right? Zero T, right? So zero T means uh, don't lose anything, right? Normally, uh, lost 2 liters per minute, right? Yeah, but then it's no losing any liter per minute, right? Okay. Now, first term, can you please calculate? So we have a dy over dt equal to 6 times 0.0175. So it's 0.105, good. And second term, we have 6y over 2000. Second term is 0, right? Okay. Same unit. So what kind of unit we have earlier? Minute per kilogram per minute. Yeah, right. Kilogram per minute. Yeah. Kilogram per minute. Okay. All right. Okay, so this will be last question, but there's 3 parts. Okay, so let me read. Suppose that a room containing 1900 cubic feet of air is originally free of carbon monoxide, CO, just using the what is called the element. I was not remembering the word. Okay, so beginning at the T equal to 0, cigarette smoke containing 6% CO, carbon monoxide, is introduced into room at a rate 0.6 cubic feet per minute. Where circulated smoke and air mixture is allowed to leave room at the same rate. Same rate means 0.6 cubic feet per minute, right? Yeah. Okay. Uh, Let A over T represent the amount of CO in the room, cubic feet, after 10 minutes. Okay, so same. So we are using the A over dt, amount of CO in the room, right? Instead of dy over dt. Yeah. So same concept, rate in minus rate out. In that case, rate times CO, like a carbon monoxide instead of salt, right? Okay, let's do that. So rate in that case will be 0.6 cubic feet. So cubic feet, cubic feet. We writing this way per minute, right? And times carbon monoxide will be how much? 0.06, right? So that will be 0.06, 06. Okay. Same concept. We have a negative. Think about like earlier salt tank in salt program problem, right? Okay, so what was it? enter, right? Enter will be 0.6. And then we don't know how much, sorry about that, the drain, right? It was a drain, yeah? Okay, talk about the drain, right? So rate out, drain. Sorry, because rate out, drain. So zero point 0.6, and we don't know how much of carbon monoxide, so we talk about Y, but in that case, A, right? Over the volume. The volume start 1900 cubic feet of air, 1900. Okay, and then we have a zero, negative zero T because same rate, right? So let me writing out. So no difference means there is no difference in and out. Yeah, okay, that's it. So that will be the A over dt equal to, can you please calculate zero point 0.6 times 0.06? So 0.036 minus 0.68 over 1900. Yeah, all right. Okay, what about the initial? Okay, so that means A of 0 equal to 0, right? Because we talk about A over T represent the amount of carbon monoxide, right? In the room. So when T equal to 0, there is no carbon monoxide in the room, right? Yeah, let me write down. Means when T equal to 0, no CO in the room. Okay? Okay, so second part, let us to solve the initial value problem, right? So IVP means initial value problem to find amount of CO in the room when T is greater than 0, right? If T equal to 0, we get 0, right? Okay. From the previously we have this one, right? So let's using that. Come on. Okay, copy. Okay. From A, we have. All right. Let's take a look the previous one. Integrating factor, right? It's been a while. So let's take a look. So from section 2.1, we have integrating factor. So I derive the formula, right? In 2.1, last page. Yeah. And then we did one question from there, right? So find the general solution of that differential equation, right? So we have to have this format, and then we are using that polynomial as e to the integral of the polynomial dx, then we're finding out, right? And then we multiply every term by the integrating by factor, right? Okay, now then we get left side and then right side, right? So check the product rule about the left-hand side. Let's write down left-hand side. Then we have a product rule. So we check that this is the product rule. F prime G, F G prime, like that, okay? And then right hand side we have e to the 9x. So overall we have left this one, e to the 4x, y, this is a from, right? And then e to the 9x, right hand side, and then we make integral both sides, then we get this. Now we do solve for y, right? Then we get the general solution here, right? Okay, so this concept, this method, we're gonna do that right now, okay? So we have this form. Now we're gonna make this form. I'm gonna copy down. Y prime and polynomial y equal to f of x, yeah? All right, so this will be y prime and this will be, looks like a polynomial because this is y, yeah? Make sense to you? Instead of a, right? So this is y and this is the function, constant function right side, right? Okay, so let us do that. Make this form. Okay, so we will have the a over dt plus 0.6 over 1900 a equal to 0.06, yeah, 36, right? Okay, integrating factor. What is a polynomial? This is P of x. Can you see that? Matching here? Yeah. Okay, so that will be e to the polynomial px, yeah, dx, right? So there will be e to the, in that case, 0.6 over 1900. We want to express in terms of t because they say so, right? A over t, yeah? A over t instead of y over x. We are using a over t. Clear? All right, so we are using dt. Now, this is a constant. We get just the t itself, right? With this number. So that will be e to the 0.6 over 1900 t. Yeah. Okay. Now we multiply everything, every side by this integrating factor, right? Okay, so let me copy. And then multiply e to the 0.6 over 1900 t. Yeah, okay. So there will be, let me using different page. Okay, so first term, e to the 0.6 over 1900 and the a over the t, yeah. And second term, we have e to the 0.6 over 1900, t missing, right? T, and we have 0.6 over 1900 constant a equal to e to the 0.6 over 1900 t and 0.036, yeah? Okay, let's check that. Check it out. About the product rule, right? So check like this one. Check the product rule, left-hand side, right? About the mu sub x, y, right? Okay, so let us do here too. Check. Check the product rule. Okay, the derivative and mu 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 sub x. So in that case, integrating factor is e to the 0.6 over 1900 t. And then instead of y, we are using a, right? Okay. Look, f g, f prime g plus f g prime, right? Okay. F prime, F prime. So F prime will be e to the 0.6 over 1900 t times 0.6 over 1900. Yeah? Okay. G, same, right? G is A. Then that will be, we can see the F prime G then. Yeah? F prime G. Yeah? Okay, F G prime, so F will be e to the 0.6 over 1900 t, G prime dA over dt, right? Okay, then it will be F G prime then, right? Okay, so we have that, then everything together, left-hand side, right-hand side, right? So all together will be uh, we will have the orange one and right hand side, which is e to the 0.6 over 1900 t 0.036. Yeah. Okay. There is a left hand side, right hand side. Okay. All right. Now we want to solve for sorry, not x. Solve for a. Now we're gonna take the integral of both sides, right? To get a. Oh, sorry. Copy. Uh, the 0.036. Okay, now integral. Okay, then we get whatever inside, right? So we have a e to the 0.6 over 1900 t, a equal to integral of the right hand side will be e to the that function and the keep the constant, right? So if function always like that, right? Keep that constant and then with the chain rule over this one more, right? Make sense? Okay, so keep the constant and e to the whatever and channel. Yeah. Okay. Now, can you calculate? Okay, I realized that I made a mistake, right? So uh we integral, not the derivative, right? So then it must be over zero point 0.6 over 1900, right? Yeah. Or we can say that 1900 over zero point 0.6 in that case, right? Yeah. Okay. All right. So in that case, if we calculate everything, this will 114. Okay. Now solve for A. So we divide by e to the zero point 0.6 over 1900t, both sides, right? And then I forgot plus C there. Hmm. Okay, so there will be, okay, so I totally forgot about the C, so divide by C2, right? I'm sorry, divide by, yeah. Also divide by e to the zero point 0.6 over 1900t, right? So this is, we can simplify, it's 1, right? It's 1, so A equal to 114. And then this one is in the denominator, so we can express this one. E to the zero point 0.6 over 1900 t to the negative power c. Yeah, makes sense? Okay, so this is general solution. And then the initial value is given, so let's find particular solution. So let me extend the page here. So we have that, and then initial we have a of 0 equal to 0. So we have a of t equal to 114 e to the zero point 0.6 over 1900 t to the negative 1 power c. So a of 0 equal to 114 e to the point, oh my gosh, t is not there, right? T is supposed to be here. So point 0, oh, sorry, point 0.6, crazy. I need a break. 1900 T, which is 0, right? Yeah. And sorry for C in that case, right? All right. So e to the 0 power, which is 1. Yeah. 1 to the negative 1 power, it's 1. So we have uh, 0 equal to 114 C. Then, wait a minute. Uh, why, hold on 1 second. Yeah, I'm very sorry. Okay. There is a plus minus mistake. Let me find out. Yeah. So here is 114 and plus C there, right? Yeah. So then this one is I express as a -1. So 114 plus there, right? Make sense to you? Because we have a plus, right? And this is a -1 power and then times C, right? So plus must be in there. Okay, so that is, I made a mistake. Okay, so we have a plus, and then this is 1. And then C will be plus C. So C will be -114. Yeah? Okay, now almost on one more question. Okay, C equal to -114. We have a general question, general solution A of T, which is 114. And here too, I have to make a plus. So plus e to the 0.6 over 1900 t -1 c, which is -114, right? Yeah. So -114, I wanna write in front. Okay, so I wrote down -114 in front. Normally we put the constant in front, right? Okay, so let's make a little bit arrange for this one. So look, note. So if we have 2 to the third power -1, there is a 2 to the -3, right? We can give it to the negative sign to the power. So I can arrange, right? So 114 minus 114 e to the -0.6 over 1900 t. Make sense? All right. Okay, so let us do last question here. All right, so we have extended exposure to CO concentration as low as 0.00012 is harmful to the human body. Find the time at which this concentration is reached. Yeah, yeah, okay. Concentration. Okay, so like a concentration is the amount over volume. So if we have amount, then there will be concentration times volume. Okay, so we have a concentration 0.00012, and then we do times volume. So what was the volume in the beginning, right? So the volume is 1900 cubic feet, right? Volume. Okay. So there will be 1900. Okay, right side will be in terms of times, right? We had A over T. earlier. Okay, not this one. Yeah. This one, right? So let's using this equation. And then we want to solve for t. Make sense? All right. Okay. Solve for t because they want to know about the time t, right? So solve for t. So left side we have 0.228. 1900t. Okay, now we move to this one, right? So we have a 0.22a minus 114 equal to negative 114 e to the point negative 0.6 over 1900t. Okay, so left side will be negative 113.772. 1900t, and we divide by negative 114. We don't have to do this way, right? So divide by negative 114. So we have 0.998 equal to e to the negative 0.6 over 1900t, right? Okay, t is here. So we take the natural log of both sides, right? So ln. So we have a 0.998 equal to negative 0.6 over 1900t, right? Okay. All right. So left side 0.998 equal to, so we have negative 0.6 over 1900t, right? Solve for t, divide by negative 0.6 over 1900, both sides, right? Okay, then what do you get? T will be 6.3 minutes. Okay? All right. Thank you for watching. I will see you in next video. Bye.